Use the intermediate value theorem to verify that the following equation has three solutions on the interval 0 to 1, then find the roots for the graphing calculator. Okay, so the intermediate value theorem basically says that if you can show the function is more than 0, or whatever your value is, in this case 0, and then less than 0 on the interval 0 to 1, then it must have become 0 at some point in between, so long as the function is continuous. Okay, so the first thing we want to analyze is this function continuous? Is it continuous? Well, it is a polynomial function. There's nothing rational going on here. There's no radicals, square roots, or anything like that. So it's a polynomial function, and all polynomial functions are continuous. So yes, it is. Okay. Then you would need to test the points 0 and then 1 in your calculator and see what do you get. Well, you don't need really a calculator for this. Let's just do it by hand. So if we plug in 0 here, you can see that this and this and this all go to 0. So we'll call this f. So f of 0 is going to give us to -3. F of 1 is going to give us 112 minus 114 plus 35 minus 3. Okay, so those together give us -2. Those together give us -5. So this is equal to 30. So you can see that it's below the x-axis here because it's -3 is its value, and it's above the x-axis at f of 1. So long as it's continuous, which it is, then it must have crossed the x-axis at least once between 0 and 1. Now, the problem asks us to verify that it has three solutions. All the intermediate value theorem can do, if we only use the endpoints, is verify that it crosses the x-axis at least once. Now, we could further break this interval down into maybe 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, and 0.75 to 1, or something like that. But the problem didn't really ask us to do that. It just asked us to use the intermediate value theorem on this interval, and we've concluded that yes, there are in fact solutions to this equation on that interval. Now, it says use the calculator to find the roots, so let's do that. So I've already got it typed in for us here. Got 112x cubed minus 114x squared plus 35x minus 3. Now, let's look at our window. Remember, we're only looking on the interval 0 to 1, so I changed x-min and x-max to 0 to 1. And trial and error let me see that I really only needed the y-max to go from -1 to 1 as well. So when I hit graph, this is what the function looks like. And we can see we have 1, 2, 3 times that this crosses the x-axis, which means that equation has three solutions on the interval 0 to 1. How can we use the calculator to find those exact solutions? Well, here's how. We hit second trace, that's calculate, and then we're going to go to the second one, which is 0. Let's choose the leftmost point, so I'm going to bring this cursor over until it's left of that first time that it crosses. That's getting close. There it is. Okay, left, hit enter, right, hit enter, and guess we don't care about doing that. And it says our first 0 is going to be x is equal to 0.14286. Okay, let's do that process again for the next one. So remember, we hit second trace, 0. Let's move over here to the next point till we're just left of it. Here's where it crosses. The cursor's left of it. That's close enough. Hit enter. And then go to where it's to the right of it and hit enter. Notice you have these two little arrows that show, yep, that's our interval right there that we're looking. Guess we don't care about that. And we get our next solution of x is equal to 0.375. And finally, the last one. So we'll go over here to the left of that last place that it crosses, go to the right, enter on guess, and we get x is equal to 0.5. So we've used our calculator to find all three solutions to this equation.